right. So thank you everyone for joining the workshop today. So for those who have a computer, you can go to test.salesforce.com and you have a little paper on your desk with a username password, and you'll be able to do the exercises as we go along. Otherwise, I'll do it on my computer too, so you'll be able to follow along. So what we have today planned for you, so it's a workshop, but still, I'm going to give you a little bit of an introduction to Prediction Builder, because I assume that you guys are not super all experts already. Are there any experts in the room already? No, okay, great. And then we're actually going to try to set it up. So we're actually going to define a machine learning problem. We're going to create a prediction to solve it. We're going to look at the model that we are going to create. And then we're going to actually create reports to monitor how our prediction is doing once it's been deployed. I'll also give you some thoughts about how you can use this tool, give you some ideas about how other customers have been using this tool. And if we have time, we're going to take a look at the roadmap so you have a sense of what's coming next. And if you have questions at any point, please ask. So you have Ed at the back of the room. You have Alpha also. So we're going to go around, help you, set it up, answer any questions you may have. All right? And if I do get to the roadmap, I'll talk about future stuff. So as usual, forward-looking statements. All right, so let me give you a very quick intro into Einstein and Einstein Prediction Builder. So AI can help address many business questions, right? I don't know your background or where you work. You might be in sales, you might be in service, you might be in marketing, commerce, whatever your business does. There's lots of questions that AI can help with. It's a lot about increasing productivity, focusing on the right things. So for example, which leads should I focus on? Or if I'm receiving service cases, which ones have the highest priority? If I'm doing marketing campaign, how to make sure that they actually resonate with the people that get them. There's a lot more, and actually we're going to see with Builder you can answer some of these. For example, how likely is a customer to buy a new product? How is a customer likely to churn or to attrit? And so on. And what we figured out at Salesforce a few years ago, talking to a lot of customers, is building intelligent apps is actually very hard, right? Everybody wants to make their apps smarter, but there's a lot of hidden complexity that you have to deal with in order to put these predictions in production. Starting with the data, you need to have access to it, and you need to prepare it so it can be used for machine learning. You need to do the data science part. You have to have the infrastructure in place. These models have to run constantly, be monitored. And then you actually have to embed the predictions in the right place. If you are just sitting in some Excel spreadsheet somewhere and you're not using them in your day-to-day job, it's kind of a pointless exercise. And so that's why we created Salesforce Einstein 3 years ago now. We like to think of it along these 4 axes. It helps you discover insights about your data. For example, you may understand, if you're trying to predict churn, what makes a customer churn. Looking at your historical data, we're going to try to predict outcome. For example, is this specific customer going to attrit in the next 6 months? Recommend the next best action to take. How can I prevent this from happening? And you may do some automation based on these predictions too. For example, send an email campaign or warn your sales rep that this customer is going to attrit or something. And Einstein is a big world. We have a whole spectrum of apps and tools that you can use. And if you're interested, by the way, we have a keynote this afternoon at 2 p.m. where we're going to talk about a lot of these different functionalities. We have a customer from Paris, actually, coming to explain how they use day-to-day Einstein in their business. So we have a number of out-of-the-box functionalities that you can just turn on, turnkey solutions for sales, for service. We have point-and-click solutions. So today, you're going to play with one called Einstein Prediction Builder. There's more. And we do also have APIs that you can use to do some things like object detection or language analysis. So now, that was just a quick intro, because here today we are in this room to actually do a workshop and actually set one together. And the tool we're going to use is called Einstein Prediction Builder. And what it is, it's a wizard. So we're not going to code. Don't worry, you don't have to show off your Python skill this morning. So we're going to use this wizard that's really designed for admins to help you solve machine learning problems. And it's aimed at admins. So people who know Salesforce well, know the data, have a sense of where the business wants to do, but not a data scientist. And the value you'll see is that it makes it super easy to integrate the predictions into Salesforce. And how does it work? We are basically going to point to a specific field somewhere in Salesforce on an object that you care about, that we want to predict, look at historical data. It works on standard and custom objects, and based on that, we'll build a model. At the moment, the predictions are done hourly, so we'll do a little trick because we only have an hour to set it up today, you see. And at the end, you get a score, and the score will be a number between 0 and 100, which will be an answer to one of two questions, either a yes or no question or a numeric prediction. Yes or no question, for example, is this customer going to churn or not? Okay? A numeric prediction could be, what is the lifetime value of a customer? What's the price of a house? Whatever, a number. Okay? By the way, we are going to play a little game at the end of this workshop, so you may want to pay close attention to some of these things, and the winners will get these maybe beautiful Einstein doors. I'll let you judge, but if you want to take one home, we'll play that game at the end of the hour. All right, so let's get started. How do you turn an idea into a prediction? So first of all, what is machine learning? It's a big field. We don't have a lot of time, but just in a nutshell, machine learning is about using past data to predict the future. Okay? So behind the scene, there's a number of algorithms. There's many of those algorithms. They find patterns in your historical data, and then you apply this model that you build to make predictions on new data. Okay? And roughly, you have two things to think about: the training set and the scoring set. The training set is basically your historical records. So for example, if I keep with the example of predicting attrition, these will be examples from your customers that you've had for a long time. And some of these customers have churned, some are still your customers. So you have examples of both. And then the scoring set will be what you care to predict. For example, it might be new customers. Like let's say you just onboard in like customers in the last 6 months, you want to predict whether they're going to churn or not. And as I said, Builder, you can generate either numeric predictions or binary predictions. Today, we're only going to cover binary predictions, so answers to yes or no questions. For example, is this customer going to churn? Is this lead going to convert? And is this student going to graduate on time? But just so you know, for the sake of completeness, you could also use this same tool to do numeric predictions, predicting a number. For example, how much this deal is likely worth, or how long will this deal take to close, let's say. All right, and this is kind of a way to look at it. So you have examples in your training set. So you have a set of people that have taken some action in the past, and then you have these new folks in your scoring set, and you're trying to make a prediction for them. So the example we're going to do today, that you're going to do on your laptop, for those who brought the laptop, will be to predict whether an appointment will be a no-show. So thanks to Edward here, we got a data set from Brazil, I think.
Yes, it is a data set that has a list of medical appointments that happen in several parts of Brazil. It's over 100,000, so each one of you and your reports, for those of you, you will have access to all that data set. So lots of medical appointments with a history of whether they turn up to the appointment or whether they didn't turn up.
So in fact, we can take a look at this data right now. So for those who are connected, you can just go. And I think the quickest way is if you go to the top left here and you click on this EPB workshop. And then you'll get access to this medical appointments data set. And you'll see exactly what type of data we have available. So it's a long list, thousands of appointments, that happen in Brazil, different regions. And you can see some of the information we have about these appointments. So for example, we have a gender of the patient, male or female. We have the age of the patient. We have their ID. We have some age brackets over 65, 45 to 54, and so on. And then we have whether they showed up to their appointment or not. That's this checkbox. So if it's checked, it means they actually did not show up. So they made an appointment online or something, and then the day of the appointment, they didn't show up, right? And others, they did, right? And that's what we want to predict, basically. We want to learn from that so that we can predict for future patients which ones are going to come for the appointments and which ones are not going to come. And you could see the benefit, to do that. there's a huge cost. I don't remember the numbers, but I remember I read a few articles. There's a huge cost of these no-shows because people are there. There's nurses. There's doctors. They can't. So they have an appointment. Nobody comes. They could have had another patient come. Maybe it was more urgent. So obviously, it's interesting prediction, right? So that's what we want to predict. We want to use that data from the past to predict for new patients whether they're going to come or not. Does it make sense? Yeah? Can you see this data? So I don't know in which state your org is, but you can easily go to this little gear icon, and you can do select fields to display, and that's how you can show more or less fields, right? For example, I can show whether they have diabetes. So I put it here, and then now I'm going to have a new column which is going to show me whether they have diabetes or not. So that's basically the data set we are dealing with. So now we're going to do the little interactive session. So let's see if people woke up this morning or if the coffee. So training set, scoring set, I explained. So training set, appointments in the past to learn from, scoring set, appointments in the future. So a good way to think about it when you're trying to set up a prediction is to divide it into 3 or 4 buckets. You need positive examples. In that case, that would be people who, well, actually, I should not say that. That's my question I'm going to ask you. So you need examples, positive examples, negative examples, records to predict, and records to ignore. So that's why I need your help. So what do you think are, in this case, positive examples?
They've signed up for their appointment.
They signed up for the appointment? Yeah. So actually here it's like kind of a reverse, but it's the right idea because we are trying to predict no-show. Okay. So positive examples would be actually people who did not come to the appointment. So in that case, what would be the negative examples? Yes, okay. So that's correct. Did I make it? Yeah, here we go. So positive examples, appointments in the past, where they did not show up. Appointments in the past where they did show up. And what would be the records to predict? Say again? So these are already there, right? We have appointments in the past where they did not show. In the future. Exactly. So these are appointments in the future. That's where we're going to do the prediction. Records to ignore, actually in these data sets, we don't have those. You have data sets sometimes where you have dirty data, for example, a lot of duplicate appointments. So you may want to just ignore those, but in that case, you don't have to worry about that. So this is basically, problem, pretty simple. So just a little trick here, because we use a data set, because of the data set we are using, and because obviously we won't wait here for months until we have new appointments, we're going to do a little trick. So we're going to pretend that today is the 26th of May of 2016. Okay? And now what I would like you to try is to go to Setup. If you go to Setup, you should see Einstein Prediction Builder. You see it for those that have a computer in front of them? So you go to Setup, and it should be right here. Yeah, you can walk around. So Ed and Alpha will walk around also to help you. So I'll give you a few minutes head start, and to see if you can basically try to set up this prediction using this tool. And for those that don't have a laptop, don't worry. I'm going to do it myself, but I'm giving a little bit of a head start for people to try it on their own. So try to see if you can set up this prediction. And the name of the object where this data is a medical appointment. So here you go. I will shut up for a few minutes. We'll walk around. Don't feel stressed out. And then in like 2 minutes, 2-3 minutes, I'll do it myself to show the others. And if you have any questions, just raise your hand. If you don't see this, raise your hand.
Yeah, any questions, just let us know. Help you out.
We'll come along.
At the end, the result is
see people are making good progress, so I'm going to start doing it myself and see if you guys can check whether you've done the same thing. So, the first step is easy. You give a name to a prediction. In fact, with Builder, you can create many predictions on different objects, right? So it's just a matter for you to kind of remember what it's about. So in that case, it's my no-show prediction. Okay. So the first step is Builder tells you to select an object to predict. Okay. And so that's where you have your historical data. And in that case, the data is on this medical appointment object. So first step, easy. You can create segments. Segments means you may have different parts of your data that you want to treat differently. Let's say, for example, in this example, that you have that some states in Brazil are very different from one another. Maybe you want to create a specific prediction for each one. In that case, we're just going to create one segment. And then the next step is you select the field to predict. So maybe you saw that you had a field called no-show, right? This was the field that had the examples of people who showed up and did not show up. So this is the field that you want to predict, the no-show field. So this part is the tricky part. That's where you want to be careful. So that's where you want to point basically Einstein to the historical records. And remember I told you we had to play this little trick, basically pretend that today is the 25th of May of 2016. So this is why here I'm saying the records Einstein should use as example are appointments where the appointment date is less than the 25th of May. Okay, so basically this now represents my history, right? And which means that anything after that will be kind of the future where I want to predict. Does this kind of make sense? Because it's usually like the tricky part. Did some of you like do that? Reach that stage roughly? Kind of? Okay.
So if this was a live org that you're doing it in, you would just use the relative value like today, would you?
You could use today in that case.
Yeah.
All right. So then the next screen basically shows you all the fields on the appointment object, right? So this is the information we're going to use to make that prediction. Okay. So that's all the information you saw. There's age, and whether they drink a lot, gender, whatever, right? And one good thing about Builder is that you don't have to think too hard about this. You can just pretty much give most of it, and Builder will take care of figuring out which field have the relevant data or not. There's a few reasons why you may want to take things out. One is, maybe for legal reason. Let's say, there's personal information in there that you're not supposed to use in model. Maybe, for example, you're not supposed to use, I don't know, like gender for your prediction, right? So usually for medical, it's not a problem because gender actually is a legitimate information to have. But let's say we're trying to predict whether someone should get a loan from a bank, right? Like gender should have nothing to do with it, right? So you probably want to remove it. There's a few other reasons, but that's one of the key reasons to remove. And then,
is there some restriction? You can based on all type of fields, or
pretty much all type of fields.
No limit.
No. Formula, everything.
Okay.
Yeah.
Text be rich text.
Say that again.
Rich text.
So text works. It's usually not the best predictors, but we also do some processing on text so that it can be used by Builder. And the last step I'm doing here is giving a name for the field where these predictions are going to be stored. All right, so that was your question. So basically, once this is deployed, scores will show up in that field. And this becomes a new field in Salesforce, very similar to a custom field, that you can use, as you're going to see, to show the results in list view and so on. Okay. And so then you click Next, and you get a little summary. Did everybody is following along? Yeah? So you get a little summary of what you've done, and then you build prediction. So you can actually do it I'm going to skip it here. Actually, sorry, before doing that, one thing that's always worth doing is doing this little data checker on the side, so you can actually try that out. And what it does, it's going to basically give you some assurance that you set it up properly. It's going to tell you whether you have enough records to predict. So Builder actually asks for a minimum of 400 records. Also tells you, how many positive examples and negative examples you have, so how many shows and no shows to the appointments. And also it tells you how many records where you're going to get predictions. So in that case, as you can see, you have lots of data, right? So if you've done everything, you should see exactly the same thing I'm doing. If you kind of followed the same steps, you should see that we're going to predict on 35,000 records. And then you click Build Prediction, and it's going to basically create the prediction for you. So in real life, that's where you go, get coffee, take a break, because Builder can take up to 24 hours to give you the results, which seems like a lot, but actually, by experience doing a lot of machine learning, is very fast. And for smaller data sets, it will be less time. So basically, this is kind of how you set up a prediction with Prediction Builder. So we've done that part. Do you have any questions? Kind of makes sense? Yep.
At what stage did you choose the positive and negative?
What is the what?
At which step did we choose the negative and positive result?
Yeah.
Because we just choose the field,
That is,
but we did not say that no show equals true, for example.
that's a very good question. So basically, when we set, in choosing that field was a pick list. Sorry, it was a checkbox that had true or false. But it's a very good point, and in fact, I maybe show you at the end, in the roadmap, we are going to make it a lot more explicit. So in the next version of this wizard, you're actually going to have a screen where you can tell, these are my positive examples, and these are my negative examples. Yeah, that's a great question. In case that was implicit because the field had a checkbox, and so it was true, false, true unchecked, and untrue and not checked.
The prediction we're going to have, like, okay, I see. So it's like positive example would be checkbox is checked.
Exactly.
Right?
Yes.
Can you use like formulas?
You can use some types of formulas.
Yeah.
Yeah. You can basically create a formula that's going to return true, false, or null. True will be the positive examples, false the negative examples, and null will be the records for which you want predictions. So that's another way to do it. In fact, we have a longer version of this workshop where we do both, but because we have limited time, we do kind of a simple version. But yeah, it's a great question. All right. So now that this is done, as I said, there's different ways you can do. Once you've set it up to kind of do a sanity check. So one is using that data checker. That's what I showed you on the side to help confirm that you set up correctly. Because if, for example, if you have like 0 records to predict, or if you have no positive examples, let's say, that could be that something goes wrong. You can create reports to make sure that it's set up correctly. Sanity check on some records. But at this point, this is what we just showed. You said, okay, my prediction is done. So now what, right? So the next thing you do is actually inspect your model. So this is something that you won't be able to do on your org because the model is still being built, but I can show you what it would look like. So once this is finished, you'll get your little prediction showing here in that menu. If you can look now, it's showing, but it's saying being built or something. I forgot the exact term that we use, being processed. And then once it's ready, you'll be able to access to something called the scorecard. And the scorecard is what you're going to use to get a sense of how your prediction is expected to perform. So that's something that's also important to understand in machine learning is really, you never know how well it's going to work until like much later in the future, right? Like for example, let's say I'm trying to predict the weather. I can tell you, like in 5 days, it's going to be like another heat wave, like 40 degrees Celsius, like we had a few months ago. And you can say, great, but you will only know if my prediction is correct in 5 days, right? Then we can see. This is the same thing, right? I'm predicting whether someone is going to not show in the future, but I don't know really, right? So how we do it is we basically use part of the data. We leave it on the side, the historical data, and we use this to test our model on. So basically, we learn on part of this data, and then we apply that prediction to what we call the holdout data set. And based on that, we see how well we do, because for this set, we actually already know the answer. So that's kind of how it works. And that's how I get this number. So this is basically the expected accuracy, that I'm hoping to get when I put this in production. So in that case, it's telling me that it should be good. And it's also showing me the top predictors. So basically, which fields in my data set are more correlated with the outcome I'm trying to predict. So for example, one of the top predictors is whether the appointment was booked within the last 24 hours. So, you could say, it kind of makes sense, right? Like if you make an appointment last minute, you're probably more likely to show up because it's probably an emergency, right? So that kind of makes sense intuitively. Versus if you made an appointment 2 months ago, maybe it was like some routine check and you went on vacation, you forgot or whatever, right? So it's kind of like what you do when you build a model. You kind of look at the top ones and you see if it makes sense intuitively. So for example, this one also, previous no-shows. So this person already did not show up before, probably has an impact. Age bracket, 65. Maybe older people, sometimes it's like, they have a problem, like maybe they need someone to take them to the appointment, and so they couldn't make it, right? So this is kind of what you do. You kind of take a quick look. We give you additional information in these tabs. So for example, you can see how each age bracket impacts the fact of not showing up to an appointment. So you can see, for example, 65 here. And if you want the full list, you actually have it. So that's more like if you have like data scientists on your team, or just for you also to spot check, right? So you get the full list of like the fields that are correlated with the outcome, and how big is the impact. So that's kind of what you do here. Any questions?
How do you, all of these fields I saw on the right are mostly formulas. I have to create the field within 24 hours so it can be used by Einstein. But does Einstein provide me insight on which field I should create so it can make better prediction?
But no. This is only based on the data you already have. So you may already have this information in your system, right? But sometimes it's not there, and that's where it becomes really tricky. And in fact, Edward, like when he got this data set, he actually said, let me try a few more things, right? Which one did you add? I can't remember now.
Features, yes, within 24 hours.
So,
that
exactly.
wasn't in the original data.
So this one was not in the data set, he added it. He said, maybe let's see if it has an impact, right? So that's why it becomes a little more complex, but interesting also, is you may want to kind of craft additional fields because you think they may have an impact.
Yeah, and all you need to that is just, whatever your business domain knowledge is, apply that, create those additional fields as features to the model, and then the model will tell you if they're relevant or not. The second one, the previous no-show, it kind of makes sense. So if people have a history of not turning up to the appointment, it's likely that they will miss the next one. And the contrary is true. If people usually go to their appointments, it's a good predictor. Maybe they will go the next time. So these things, you just need to apply your knowledge of the domain and create new fields for those.
And that's where domain knowledge is very important, right? So what Einstein helps with is makes it very easy to do the kind of machine learning, processing, running the algorithms part, right? Like I didn't run any algorithm here. Like I didn't talk about it, but actually behind the scene, we run a bunch of algorithms, with this data, like in that case, logistic regression, right? But you didn't have to code any of this. What we need the person to know is have some knowledge about the domain. In that case, like if you're in the medical domain, you may have a sense that, like whether someone has not shown up before is a good information. Or whether the appointment was booked in the last 24 hours, that's probably also good information. But yeah, great question. Any other questions? Yeah.
Do you combine fields to be able to predict scores, like for example within 24 hours and previous no-show?
Yes, so behind the scene, that's where the algorithm is going to do. It's going to look at fields together and see how they interact. Yes, that's basically what happens. Yeah.
You get to see that on a certain screen?
So you get to see kind of so that's basically what these numbers tell you. So it doesn't tell you like how they work together. We don't give you that level of detail, but it tells you at least like the weight or the impact it has on the model. So for example, you can see that within 24 hours has a high impact, first of all. So it's one of the most important things. And also it's negatively correlated, which makes sense because we're trying to predict no-show, right? And if you booked in the last 24 hours, probably going to show. That's why it's negative.
In this example, within 24 hours seems to have a big impact.
Yeah.
But I don't see the creation date.
You don't see the
Created date.
created date.
Normally it's linked.
That is true. I don't know if it's somewhere down there.
It's a creation date if we ignore it because the date that we created the record, we both plotted.
Yeah, that's a reason also.
The creation date is not as relevant. Now, the appointment date and the schedule date, those two fields are in the data set. What happens is that the model that we ran, they determined that they were not as important. Otherwise, it would be there.
And you have other things, like you have a day of the week, for example. So apparently, like Wednesday, the fact that it's on Wednesday actually matters. Maybe Friday, people are more likely to skip, right? But yeah, so this kind of exercise, like when customers put it together, actually we kind of spend a lot of time with them, going through that, trying to say, hey, does it make sense, does it not make sense? And then that's when you start thinking, well, maybe we should craft one more feature or one more field, or there's maybe some other data somewhere else that we have not considered that we could import or something like that.
Yeah. So it's important. This is a good point. It's important what you see there, but it's also important what you don't see. Because what you don't see is, oh, that should be in there.
Yeah.
But actually, the model is telling you that it's probably not as important as you thought it was.
And that's the beauty of machine learning. Like that's why, when we went to the field selection, I told you, don't be too selective. Because if you only pick the ones you already know, well, guess what? It's going to tell you what you already know, right? The beauty is you put other things and then you discover things like, hey, I had no idea that day of the week was so important for my prediction, right? So that's why you have to, add a few more there, and that's how you learn interesting insights. And most of the customers we work with, they, kind of make sense. Like there's a lot of things that they already know, but there's always like this one or two golden nugget that's like, hey, that's really strange. Like I had no idea.
The day of the week we need to think about it before because it's also from here.
Say it again?
The field appointment day of the week.
Yeah.
It's created.
Yeah, in that case it was there. So if it's not there, that was kind of this question, right? Exactly. If it's not there, then, but maybe by doing this, you have these discussions also. You look at this, you're like, it looks fine, but there might be something missing. What could we do? And then that's when, so usually this is an iterative process. Like in our experience, it never works the first time. You try it, you're like, okay, but then we tweak it. Okay, that we can add, that we can remove, that we can change, right? You do it at least 3 times. And then eventually you get to something that kind of makes sense.
Yeah. And going back to your point, actually schedule date is the 5th element. So the appointment date is not as important, but the schedule date, when you booked it, is important. But yeah, that's an insight that you wouldn't have never guessed. When you booked it is more important than the actual date of the appointment.
Yeah.
So see, we're already having all these discussions, right? And it's not something we even care about that much. But imagine if you really cared about it, then you would really spend a whole couple hours really thinking through this problem. Before and during and after. Yeah, it's really it's a process. All right, so let me show you a few more things. So we are running, I think we may run a little over, which I think is okay because we started 10 minutes late, checking with the person in the back. Okay. But if people have to leave on the hour, no problem. I'm just going to keep going a little longer because I think the next section is at 11:20. So. Yep. Yep.
I didn't fully understand the 24 hours time frame. If every 24 hours, the prediction is gonna recalculate all data and give new prediction.
So the way it works is the model, we do it every month. Okay. Because usually life doesn't change that fast, right? But then when we create the prediction, this is done every hour. At the moment, actually we are working on making it pretty much real time. But basically every time, right at the moment today, every time something changes, like let's say the person called and say, actually I have diabetes, that's it. And you didn't know about that person before. So you change that information about the patient, right? So then the prediction builder will recalculate the no-show score based on that information within an hour. Right? And in the future, pretty much in the next few minutes, when something changes, it's going to be scored again. So the score will change over time if you get additional information. In that case, for this type of use case, probably it won't change that much because your patients are your patients, But there's other use cases where it's a lot more dynamic. Information changes all the time, and so the score will change more often. All right, so a few things to look out. We already talked about a few. So you can look at that score that I had. Usually, the higher the better, but actually there's some also things to know here. Like if it's too high, it might be a problem. And I'm going to skip the rest for the sake of time, because we already had a good discussion. Okay, so now we put our prediction. We created it. It looks good. So now what? You're saying like, great, I have my prediction. What do I do? So now, typically what you do is you want to monitor how it's doing in production. And now you understand why we did this little trick also of this date in the past. So now, basically, we're going to assume that the model you just built has been deployed actually on that date, whatever it was, like the 5th of May of 2016, and it's been running now a few months, right? So you actually have information about, which ones did you predict actually showed up and which one did not show up. That's when it starts becoming really interesting, because that's when you'll be able to say whether it's actually working or not, right? And so here, what you need to do is you're going to be able to compare your predictions to reality, right? So what the data you need is what the model predicted, so basically the score of no-show, and what actually happened, right? And so there, I think we have time to do a few of these. So you basically can follow the instructions on the screen to get that information. So what you want to do is you want to first go to the table view, but switch to medical appointments 2. So medical appointments 2, it basically exactly has the same data as medical appointments 1. So all the information about the patient. But in the 2, what we did is we basically have a score. Like, pretend that it's been running, and so we created this. We copied the data set, we added the score. And so you can go to the medical appointments 2, and then you can select a few fields that we saw were important. For example, we saw that previous no-show within 24 hours were important, so you can kind of add them in the list view. You can display the field that we are trying to predict. So one of the fields you select is no-show, right? And then you can also display the field that holds the prediction. So in that data set, we actually called it no-show score, right? So this score is a number between 0 and 100, right? And the higher the number, the most likely our prediction was, the most likely this person is not going to show up, right? What you want to do also is you want to filter out no-show scores with no scores, and then sort. So yeah, so if you follow these instructions, you should be able to see something. I have it on the next slide. So if you have are you able to go to reports? Both that have a computer in front of them? Yeah. Just follow the steps, and in a few minutes I'll share what you are saying. And if you have any problems, just raise your hand. Yeah, so you have to go to filter, this little guy here. And then you say add filter, and you say no show score not equal to run this random. So not equal, and equals not equal. I think just put a double quote. And then you can solve by the score. All right. So now I'm going to show here what people are saying. So basically, you see this, right? So if you sort by no-show score, so you can start by sorting so that you have the higher scores at the top, and that's where you kind of spot check, right, how it's doing. So you can compare what actually happened, which is no-show, this column, to the score. And what you can see is that when the score is high, so we predicted that they would not show, basically, most of them did not show up, right? Like the top, they did not show up. All these are checked. But not all of them. No, that's machine learning is never 100%. It's a probability, it's a likelihood, right? Like weather prediction or anything else. And so you'll find a few there if you scroll down, basically the lower you go, the more errors you'll see, right? But mostly those at the top are no-shows. And if you sort by the reverse, so if you start by the lowest score, you'll see the opposite. You'll see that at the bottom, pretty much all of them that we predicted had a very low score of not showing that actually did not show. Okay? So you can say, well, it seems to be doing okay. So now the next thing you can do is to summarize in a report, right? Yes?
So you're supposed to filter the no-shows equals 0?
Equals anti-string.
Anti-string.
Yep.
So 0 is a value. It's a result.
0 could be a result. Actually, I don't think so. Actually, I think we start at 1. But you can filter by empty string. Basically, it's going to be empty string.
Okay.
Yeah. It's just to remove the training data.
Yeah.
So now if you follow these steps, we can create another report. It's going to be a lot prettier, you'll see. So you can start, again, a report on the medical appointment 2 object. You're going to do that same thing. You're going to filter records that were given a score. So you're going to have no-show score not equal to empty string. You're going to group rows by prediction score, by no-show score, group columns by no-show, and that's all you have to do. So if you follow these steps, you should get a table. If you have any problems doing it, just raise your hand. People in the back are very friendly. They can come and help you. Are some people managing, getting there? Sorry, I'm going a little fast just because clock is running. So if you've done that, you should see something like this. You should see a table by scores, right? And again, what you can do is you can spot check. You can look at the top, and you can see that when the prediction score is low, you have more of these unchecked, which means most of these people actually showed up to the appointment, right? And again, not all of them. So in that case, for like the scores of 5, we have 760 appointments that were kind of correctly predicted as they showed up, and 24 that didn't show, right? And if you go to the bottom of this, you'll see that mostly for the high scores, you have more, or you only have on this column, meaning they did not show it. Are some people saying that? Yeah? No? I'm going too fast. Should I go back here really quick?
But ultimately what you're doing is you're comparing your model. You're building trust in the model by looking at, did the model get the answer right? And as long as it is, X% of the time, and that X you're comfortable with, then it's a good model that you can use to prioritize your actions. If you know that somebody's is not going to show up, send them an email, send them an SMS. Maybe not all of them will be right, but most of them will be right. So this is what the point of this exercise. How do you build trust in this model? By comparing the actuals versus that prediction. And don't worry if it...
Yeah, don't worry.
If you
I'm going to show exactly to everyone what it looks like. It's just so you have, so it's a bit more interactive, but it's just, as Ed said, to give you a sense of how you, once you deploy this, how you know it's working, right? So eventually you get something like this. And we like to visualize things. So what you can do next is you can create a chart. So if you manage to get to that stage here, you go to the top right of the screen, and there's an Add Chart button, okay? You can click on that chart, and it's going to do like a bar chart. What you want to do is click on the little gear icon to edit chat properties. So that's on the lower gear, not the higher one, not the setup. The one near the chart, there's a little gear icon. And you choose a stack column, okay? And you can ignore 5, you can just run it. And then once you've done this, you'll get this. Few people are there. Getting there? Okay. So what do we see here? So here we see the scores. So we can see the range of scores, right? Like from 5 to 91. Again, the higher the score, the most likely, we predict the person will not show up to the appointment. And you see basically the number of true and false, right? So the false are the light blue and the true are the dark color one, right? And you can see that basically with low scores, there's more of the light blue, right? And then the more you go the higher score, the bigger the proportion of dark blue. And so again, that's how you can kind of get a sense of how well you're doing in your prediction. And because we're running out of time, I'll show you kind of the next step you can do, because it's kind of like too much information in a way. And usually what you try to do is you try to put that into buckets. That's the way to do it. So instead of having like a bucket for each number, you kind of create buckets, fewer buckets. And in that case, I created these buckets. So I grouped by 0 to 20, 21 to 40, and so on. 5 buckets, basically, every 20. And then if you were to do this, it would show up like this. So it's kind of easier to consume, right? Like you get for each score bucket, the ratio of true and false. And then you can see, that basically in higher buckets, and you can't see here because it's too small, but these are pretty much all dark blue in that case for the high scores. And that's what you want to see. You want to see that for the higher the score, the more you're accurate, so the more no-shows there are. So actually here, it's pretty much all no-shows, here the same, and then, in that one, it's pretty much all shows. Any questions? So again, just to take a step back, we created a prediction. We don't know how it's going to perform, right? We got this little scorecard. It was the expectations. I forgot the score was like 75. So roughly the accuracy should be around 75. Right? That's what it means. But to know for real, you need to compare predictions to reality. So then we're doing this little time travel thing. We pretended that we had this already, that this model had been running. And so doing that, we can compare prediction to reality. And that's what you see here, is basically this prediction versus reality calculation. And that's where you can get really your true accuracy metrics, basically. So it's kind of the end of the practical part. I'm just going to go really fast into a few things, and then we're going to play the game. And Ed, you're going to be playing the game, right? Yeah. All right, so that I skip. So just to give you a few more ideas, because we talk a lot about medical appointments, I don't want you to leave and say, hey, Einstein is for doctors. It's all about predicting no-show appointments. So there's a lot more you can do. So these are some of the examples that we see. So basically, you can do a prediction on any standard or custom object in Salesforce. Right? It's a tool that you can use for many use cases. And that's what we've seen. Customers, they do it to score the likelihood of an opportunity to convert, likelihood of a customer to buy, the time to close a deal. Right? If you're in service, you see customers, they like to predict whether they're going to, customers are going to treat, or their customer satisfaction, the likelihood of a case to be escalated, the time it's going to take to resolve a case, going to be a day or 3 weeks or something. A very popular use case, and if you come to the Einstein keynote, you'll see a customer talking about that, is predicting late payment. Hey, how likely I am that my customer is going to pay late? You can do customer attrition. Hey, you can do employee attrition too. What's the likelihood that Ed is going to leave Salesforce next week? I can try to predict that. Or likelihood to accept an offer, right? And so on. We actually have nonprofits using it, for example, education. What's the likelihood of a student finishing up their schooling? Or in travel, what's the likelihood of a passenger becoming a frequent flyer, for example? Or to upgrade to a first class, let's see. So, it's kind of your imagination is the limit, with this tool. As long as basically it's something you can ask the question yes, no, or a number, and you have the data in Salesforce, and it's not too messy, it should work. And we're going to play the game, right? So I need to go to this other thing.
Yeah, so this is your chance to get your hands on one of those gentlemen over here.
Could I just ask a quick question about the likelihood component in
Yes.
terms of putting that on the page? I've just gone and didn't see it on the. Is it just it's not on this org? Or?
So the likelihood just becomes a field. So that, you know, when you went to medical appointments number 2, there was this extra field. It was called no-show score.
Yeah, but on your little screenshot on the previous slide, you had a likelihood and it had the positive factors, you know, that were contributing to.
Of the factors?
Yeah. So on the previous slide, you had a little component there, which was your.
Let me see. Which? Oh, this one. This is forward-looking. Yes. At the moment today, you don't get these little factors. We have them, we just don't expose them yet. That's going to come in the spring release. Yeah. So at the moment, you just get the score. Yeah, good observation.
And unfortunately, part of the slides that we're skipping because of time, I talked about the roadmap. So maybe, I don't know if it is, no.
I think we're a little
We have
over.
5
So,
minutes,
yeah.
so
So let's play the game.
apologies.
It's more fun.
Come and meet us at the booth. We can talk about this for hours.
So Ed, how do we do this?
Oh yeah, just leave it right
Oh yeah,
there.
there you go.
Just leave it right there for every one of you. If you can place your mobile and go to kahoot.it, and when you get asked for a PIN, that's the PIN number that you need to enter. Basically you're gonna get asked. So once you get there, just let me know. I can see some names already popping up. So
Everybody should play.
yeah, it's your chance to. So the top 3 players will get one of those 3 little Einstein plushies. So are we all ready to start?
Right, I see still more people.
Yeah, no, we're still waiting for more.
Do you want to run it?
I guess you can just.
Kick start? But do I need to like,
That's,
after
yeah.
20 seconds, do I need to do something? Or?
I don't know. I think we're pretty much ready to start. Are we? Anybody
Okay,
else?
wait, before we start.
Yeah?
So just so you know, so you're going to have
Yes.
4 options to start from, to choose from, right? So of course, the goal is to find the right answer, but also it's a game of speed. Meaning you get extra points if you answer faster. Of course, if you answer faster correctly. There's no point for answering faster the wrong answer. But just so you know, it's about right answer, but it's also about speed. Are we ready?
You will get 6. So one more thing, you will get 6 questions.
6 questions.
Multiple choice. There will be 4 choices on the screen. Each choice will have a color. So when you see the question on the screen, just tap at the color that has the answer that you want to provide to that question. So 6 questions should be easy if you've been paying attention.
And you can play on your mobile, by the way.
And
It
you're
doesn't have to
playing
be-
on your mobile.
Yeah.
Absolutely. So let's get this
started. All right, first question.
Let's see. Start.
You want to read it? Ta-ta-ta.
Let's see.
Are you ready? All right. Which one of these can you build with Einstein Prediction Builder? Numeric predictions, time series forecasting, clustering, or multi-class classification? All right, I see 11 answers. I think we are 11 players, no?
Yeah.
So I think everybody answered, and everybody got it right.
All right. Perfect. Well done.
Pretty good. Looks like people were actually listening.
I think it's the fastest.
That's awesome. So I think you get an intermediate ranking each time. All right, so the ranking is based on the speed, because everybody got it right, right?
Oh, yeah,
So it looks like Johnny is on top, followed by Steve and M. Bailey. All right, but don't worry, there's 5 more questions. So let's keep going. Next question. When setting up a binary prediction, what does Einstein need to learn from? Positive and negative examples, only negative examples, only positive examples, positive or negative examples. Wow, people are playing super fast and they get it wrong every time. It's amazing. So again, everybody got. We need to make this game harder. So,
Let's see who's fastest.
so Johnny is still ahead. I think like M. Bailey got a little higher, and then Loic is third. But Steve and 2 are really close. So 4 more questions. Next question. When Einstein Prediction Builder makes a prediction, what does it look like? A number, a true-false statement, an emoji, or a formula? This time there were different opinions. So the correct answer was a number, so 5 people got it. And it looks like there was some confusion around the true-false statement, so it means that I need to explain better next time, so it's also good feedback for me. So let's see what happens now. So Steve suddenly jumped to first place, followed by 2, and Loic and Johnny is 4th, so maybe able to come back. There's 3 more questions. All right. How can you monitor your predictions once they are deployed? You can do it with your smartwatch, you can call Salesforce support, you can count the number of predictions, or you can create reports that compare predictions versus actuals. All right, So it is number 3. It's not by counting the number of predictions, although in some ways you're also doing reports. So going to the ranking. Oh, Steve, Steve is burning. I don't know what it means.
On fire, man.
Steve is on fire. 4 correct answers in a row. Awesome. And Loic and 2 right behind. 2 more questions. Where in the org do you see the quality of your prediction? Bulk jobs monitoring, reports and dashboards, view scorecard, or Einstein readiness assessor? And it's a view scorecard, indeed. It's kind of a tricky question, right? Because you also talked a lot about dashboards, but yes, it's view scorecard. And Simon beat the burning Steve. Combo breakers. 3 players just dropped their answers, streak of 4. All right. So this is the last question. That's where the plushie is. Who's going to win the plushie is going to be decided. So are you all ready for the last question? Why might you remove a field from consideration in an Einstein prediction builder prediction? To shorten the scorecard, to make it run faster, to remove unwanted bias, and or to avoid the field limits. In fact, I'm not sure I even covered that thoroughly today. I think I kind of skipped it. So let's see if people have
Good idea.
can guess it.
Yeah.
Yes, you said.
So let's see. Oh, very good. To remove unwanted bias. So now, of course, everybody is waiting for me to click on that next button. But I feel like waiting a little bit so people stress out. No.
It's always the same.
All right. So Simon, who is Simon? Simon gets a plushie. And then Steve, who's Steve? Steve gets a plushie. And then 2, who is 2? 2 gets a plushie.
Oh, guys.
Very good. So thank you all for joining. I hope it was fun. I know it was a little rushed, but I hope it was interesting. 2 p.m. Einstein keynote. If you want to learn more, please come and join us. Thank you.
Thank you very much.